Hey guys, today we're going to look at question number 2 on the CSEC Geography, and that's the 2024 paper. Stay tuned. I see the comments and requests and I will act on them. Please remember to follow Geography World channel on Instagram and Facebook using the link shown on the screen. Please remember to like, share with your friends and subscribe. For person wishing to contact me privately, you may email me at geographyworld100@gmail.com. The link will be posted below. Question 2 shows us figure 2, which basically shows us the movement of water above, on, and under the Earth's surface. We are to study the figure and answer the questions that follow. So, the diagram that we're looking at, it is basically showing us the movement of water above, on, and under the Earth's surface. So, for part A, we are to name each of the following features that are labeled A to E in figure 2. Now, at A, we have precipitation or rainfall. At B, we have the water table. At C, we have aquifers. At D, we have springs or sources of water. And at E, we have streams, river, or tributaries. Just to go over, at A, we have precipitation or rainfall. At B, we have water table. At C, we have aquifer. At D, we have springs or sources of river, and at E we have streams, rivers, or tributaries. Once you are able to properly label A to E, then five marks belong to you. So part B to question 2, part B. Part 1 asks that you define each of the following terms. So we're defining the term condensation and transpiration, and we know that these are terminologies that are associated with the water cycle. So condensation is the process whereby water vapor converts or turns into liquid, while we know that transpiration is essentially evaporation of water from the leaves or from plants. So condensation is a process whereby water vapor converts or turn into liquid. And we know that sometimes condensation can appear as dews or other forms of liquid, while transpiration is essentially evaporation of water from the leaves of plants. Once you were able to define both terms correctly, then a total of 4 marks belong to you. Question 2, part B, part 2 states as that we state two characteristics of each of the following drainage pattern. So we have radial and we have dendritic. Now, we know that the radial dendritic, as shown in the picture, it develops around a central elevated point. So it usually develops on a highland. And then the fact that it develops around a central elevated point, the streams, they basically radiate outward from a central high point, and it usually develops on a volcanic dome. The tributaries, they form a summit which flows downwards and drain in all directions. So the fact that it develops on a peak, the peak of a volcanic dome, the streams or the tributaries flow downward and they drain in all different directions. So if you were able to list any two for radial, then 2 marks belong to you. The dendritic drainage pattern, it is found on a relatively gentle slope with a uniform geology, and it looks like branches of a trees, and it's usually found in area that have homogeneous material. Now, once you were able to identify any two characteristics, and you can see the picture to the left of the page, that is what a dendritic pattern looks like. Once you were able to identify any two characteristics, then a total of 2 marks belong to you for that section. So 2 for radial, 2 for dendritic, then a total of 4 marks belong to you. Question 2, part C, asks that we explain how waterfall could develop in the upper course of a river. Now, when we talk about a waterfall, we're talking about a sudden step in the long profile of a river, which is often formed when a river crosses a relatively hard band of rock. It may also form when a river flows over a cliff or escarpment. Now, it erodes the weaker rocks beyond, which leads to the formation of a steep side, which the water creates a plunge pool. Over thousands of years, as the water continues to erode, it continues to dig the plunge pool deeper, hence creating a steep-sided waterfall. Now, the picture that we are looking at, in picture A, it is showing where we have a band of soft rock and a band of hard rock. Hard rock, like granite, they are hard to erode. It takes thousands of years for it to erode. So what the river does, or the river water does, is that it erodes the band of softer rock. Now, as it erodes the softer rock, it creates what we call a plunge pool at the base. As the waterfall flows over, the plunge pool is dig deeper, and this is usually due to erosion such as hydraulic actions. The plunge pool eventually will cause the overhanging cliff face to fall off, because it will start to the root will be weakened, which basically leaves no support for the cliff itself. So it will basically collapse. Once it collapses, it leaves behind a steep-sided waterfall, or a steep-sided cliff with a waterfall. So we basically say that the waterfall is retreating, and this is something that is continuously happening to that area, or to any area where we have a waterfall. Question 2, part D, asks that we explain how caves, arches, and stocks could develop from an headland along a coastal region in the Caribbean. And I went ahead and I provided a picture so that it is easier for me to explain whilst looking at the picture. So, weakness in the cliff or the headland, such as joints and faults, will erode the base of the headland to form sea caves on opposite sides of the headland. So where we have one, that's the crack or the faults, and those, due to erosion, those will enlarge to form sea caves on both sides. So where we have two caves on the opposite sides of the headland. Over time, the sea caves become enlarged and eventually join to form an arch. So at 3, that's where we have the arch, where the two sea caves, they meet and they create that arch. Now, weathering and erosion processes enlarges the arch, and the roof gradually becomes thinner. Eventually, the roof of the arch collapses under its own weight, leaving behind an isolated pillar of rock that we call a stack, and the stack is at 4. So once the top of the arch roof collapses, it leaves behind the stock, which is 4. The stock So gradually the stock is eroded until all that is left is a low rock outcrop exposed only at low tide, called a stump. So at 5, that is where we have the stump. Once you were able to answer this question, a total of 6 marks belong to you. And please remember that you can also include sketches. It basically helps with the grading. So once you were able to answer all questions correctly, a total of 25 marks belong to you.
We are at the end of this video. Thank you for watching, and please remember to like, share, subscribe, and turn on your post notification bell in order to receive more videos like these. Leave comments below suggesting topics that you would want me to present on. In the comment section below, comment the name of your school and the territory for a shout out in my next video. Until then, bye.